Okay, this is my hot water heater project. I kind of enjoy doing electronics, and anyway I decided to do a little make a hot water heater to do my electronics on. And anyway, this is these are I have two 1-ton compressors here, and they cascade into each other. This is the hot one, makes the domestic hot water. This here's the exchanger to holds about 3 gallons of domestic hot water. Then it pumps into a 40-gallon storage electric hot water heater that's just used for storage. And then down below that is the evaporator. It holds 3 gallons. It's glycol mix, and right now it's just tempered in through this pump up here, and all that gets replumbed after I get my filled loop in, ground loop. So anyway, I've got gauges for the cold. This here's for making the chilled water, the compressor that makes the chilled water, and this here's the gauges for the domestic hot water compressor. And I've built myself some electronics to control all this. I've got a board here that controls. Oh, I put some resistors on my TXV valves. I wanted to cover that a little bit. That way I can control them. Of course, the compressors do the cooling of them, and then when I have them turned down a bit, choked off a bit, and then when I want flow, then I can control my flow with my electronics. I just hit a little 110 volt to the resistor that's taped right underneath here, and it heats that bulb and opens the valve for me. So I can keep these compressors running at almost exactly the same temperature. I usually run this hot water one at 195, and then the back one goes about 170, the discharge temperature about 170 on it. And anyway, I run these little heaters. These here open up the TXV valves. These here are my pumps, and down here I'm running my isolation valves so I don't get migration. And then these two bottom ones run the compressors. They're just running off of little triacs. I got my copper heat sink here. It's just some scrap copper I bolted on there to help dissipate the heat from those solid state switches. I take temperatures. I don't have all my temperature probes set up, but I'm taking temperatures off my discharges, and I'm taking temperature off my evaporator, coming out of the evaporator, and coming out of the condenser. I'm taking temperatures, and I'm also taking temperature on my hot water tank over here. Eventually I will take temperatures. I'll kind of change that so I can get better temperature readings from different places, and write software to go ahead and do some calculations on delta T or whatever, and all that good stuff. So anyway, I'm going to run it, get it started here a little bit so you can see what it does. Let's start here. This here compressor comes on first, and you can see it building pressure there pretty rapidly. But then this compressor will come on and take it down. You can see the exchanger that takes it from compressor to compressor is just a coil back here. Let me get a little light. I just got a coil here, and there's a line inside of that line, and a little drywall dust on there. But that's where I exchange pass it from one compressor system to the other. So again, this here's the hot water tank. The pump it out of that tank. And the chilled water's down here. We've got 26 degrees there now. You can see my discharge temperature's there, the hot water and the chilled water compressor. This is coming out of the cold exchanger, and this is coming out of the hot condenser. I guess this would be the evaporator, cold evaporator. And this is the hot water temp in this tank. Goes to 105, and then when it goes up to 106, the pump comes on and takes it out of there. I have it set up so that the cold exchanger, when this hits 4, it'll kick this pump on up here, and it'll put fresh water in here. This is starting to ice up pretty good. I don't know if you can see it really. And I guess I'm gonna, so this doesn't get too long, I guess I'll stop it there. You can